Let's go to Code Milkers. Today's question is LRU cache. LRU standing for least recently used. So I solved this problem already. I'm going to go over my solution. First, let's talk about the problem. Design and implement a data structure for least recently used cache. It should support the following operations: get and put. Get means we are retrieving the value, which will always be positive, of the key we pass to the get method. If the key exists in the cache, we return the value. If not, we return -1. Second method is put, and we are either setting or inserting a new key value pair. So set or insert the value if the key is not already present. When the cache reached its capacity, it should invalidate the least recently used item before inserting a new item. The cache is initialized with a positive capacity. Could you do both operations in O in constant time complexity? I did not do constant time. Most of my operations are linear time. And one thing about the put method is that if you already have the key value pair, let's say 2 and 1, 2 being the key, and then you pass it to 2, the new value would be 2. You can overwrite existing key value pairs. So here's one example. We initialize the cache with a capacity of 2, so that means that the most amount of items we can have in the cache are 2 key value pairs. Then we're just assigning different key value pairs to it, returning stuff, and here we go. So basically, you just need to keep track of which is the least recently used and have a pointer towards that so that you can access it extremely quickly, and then keep updating what was the most frequently used element. So the least recently used is always at the front of it. That was at least my solution. So in my constructor function here, I've got 4 different properties initialized. Capacity is just the amount of key value pairs you can have. So this property lets me access the length that it can be in a constant time. Then we have this.store. This is the actual key value pair object storing mechanism. Then we have entries, and entries is the amount of key value pairs right now in the store. And then used order has the same length as the entire store, but it's just the keys that are currently in the store, and they're in the order of when they were most recently used. So the least recently used is at the front, which means we shift to get rid of it, and the most recently used is at the end. So we know whatever's at the end was the most recently used, whatever's at the front is the least recently used. Here is the get method. So here we're checking if the store has that key, and if it does, we execute this code. If it doesn't, we just return -1. It's very simple. So here, if it is not undefined, which means the key exists, we need to find where the where that key value pair is in the used order property. So then we can update the used order and place that key at the end, so we know that it is the most recently used. Then we just return the value pointed at by that key in the store property. Now here's the put method. It's a little more complicated. So this first condition, we're checking to make sure that the key already exists in store. So if it does not exist, wait 1 second. So it is not undefined. So this means it does exist already. So this is basically just updating an already existing key value pair. So in that case I gave you earlier where it's 2, 1 and 2, 2, you would update the value to 2 instead of 1. And then here we're just updating the most recently used. Here is if the entry does not already exist in store, we need to check first if entries is equal to capacity. Because if entries is equal to capacity, we cannot add a new one. We have to remove the least recently used. So we're shifting the first element from used order, which is the least recently used, deleting that key value pair, and then subtracting entries by 1 so that we know we can fit one more thing in to the store property. And here we are just assigning the key value pair, pushing the most recently used key, and updating the entries property. This solution is definitely not the fastest. When I ran it earlier, at an average runtime of beating about 28% of JavaScript submissions. So we'll see what it does here. 30%. So it could be faster. I'm going to work on refactoring it, try to get it to constant time. Hope this helped. Have a good day.